This is Odum Maths. Please don't forget to subscribe, like, and share this channel. So please, today let's look at logarithm, the change of base. Logarithm, change of base. This time we are going to work where we have a certain base different from another base, or logarithms of a question having different bases. Okay, so let's start. Now, if A, B, and C are positive integers, or positive, okay, let me change it. So positive real numbers are positive real numbers, then log B base A is equal to log B base C over log A base C. Okay, if A, B, and C are positive real numbers, then it means log B base A is equal to log B base C over log A base C. So here, formally, we have log A with a base, log B with a base A. Now we've introduced the third variable to be a base. So log B base C should be the same as or over log A base C. So the base here should be the same as this one. Okay, so let's look at some small proof to this. Now let's log B base A be equal to a certain variable x. Okay, a certain variable x. So we can say that B is equal to A to the power x. B is equal to A to the power x. We are just changing this to indices. So this should become a base here, and this becomes the exponent. So with this one, let's introduce log of another base C to both sides. So log B base C should be equal to log A to the power x base C. Then we need to invite the third law, that is log B base C becomes x log A base C. Okay, so here we need to divide both sides by, we are solving for x, we need to divide both sides by log A base C. So log A base C, then log A base C. So x becomes log B base C over log A base C. So x becomes log B base C over log A base C. Okay, but x is equal to log, here the top one, log B base A. So therefore we can say that log B base A is equal to log B base C over log A base C. Okay, so therefore the first one, log B base A is equal to log B base C over log A base C. Then we should not also forget that log B base C is equal to 1 over log C base B. Okay, we should put this also in mind. So log B base C is equal to 1 over log C base B. Okay, so let's look at some examples. So let's look at these two examples first. Now the first example, the first one, so find the solution set of A, log x base 2 plus 4 log 2 base x equals 5. B, log into bracket 2 minus 3x base 3 equals log 6x squared minus 19x plus 2 all base 9. So let's take this one first, then after we'll look at this one and solve more examples under change of base. Okay, so for the first one, the question A, log x base 2 plus 4 log 2 base x equal to 5. Now we said that log A base C is equal to 1 over log C base A. So we can change either this one or this one. Okay, based on this. So here, I am going to look at this one. So that is log 2 base x becomes 1 over log x base 2. Okay, so I'm just going to put this here. So substituting this one into here, we have log x base 2 plus 4 times 1, the same 4, over log x base 2 equals 5. Let me continue from the side. Now, with this one, we can let me do it here. Let's y be equal to log x base 2. Okay, so where I see log x base 2, I'll put y there. So this place becomes y, then plus 4 over y equals 5. So this is going, I'm multiplying through by y. So y squared plus 4 equals 5y. So y squared minus 5y plus 4 equals 0. Okay, so here the coefficient here times 4 is 4. Factors of 4, 1, 2, 4. So plus or minus 1, plus or minus 2, plus or minus 4. Then we can use 1 and 4. So 1 times 4 is 4. The factors, we have plus or minus 1, plus or minus 2, plus or minus 4. Okay. Now from here, I'm going to select negative 1 and then negative 4. So that negative 1 and negative 4 will give me negative 5. Negative 1 times negative 4 will give me positive 4. So that is going to be y squared, then minus y minus 4 plus 4. So this is 4 minus 4y equals 0. Okay. So y out, y minus 1 on this side. Then minus 4 out, y minus 1 equals 0. So this is going to be y minus 4 and then y minus 1 equals 0. Okay, so the answer is y is equal to 4, y is equal to 1. But let me continue. Okay, so y minus 4 equals 0, y is equal to 4. Then y minus 1 equals 0, y is equal to 1. So therefore, y is equal to, but we are not done because we said y should be equal to log x base 2. Okay, so in this case, let's take the first answer. So 4 is equal to, let me write it here, log x base 2 is equal to 4. So we're changing this one to indices. That is going to be, x becomes 2 to the power 4, and x is going to be 16. So the second one, that is this one, log x base 2 is equal to 1. Sorry, is equal to y. That is what we said earlier. So it means that log x base 2 is equal to 1 because y is 1. Now this is x becomes 2 to the power 1 and x is going to be 2. So x is 2 or 16. Okay. Okay, so now let's look at the b, which says log 2 minus 3x base 3 equals log 6x squared minus 19x plus 2 base 9. Okay, so but from log b base a, we said this is the same as log b base c over log a base c. Okay, so from this side, we can say that log into bracket 2 minus 3x base 3 is the same as log into bracket 6x squared minus 19x plus 2 base 3 over log 9 base 3. So instead of getting a new number, I have used 3, and which I will get the same answer. Okay, so with this one, we can look at this to be 3 to the power 3. So log 2 minus 3x base 3 can be, or is equal to log bracket 6x squared minus 19x plus 2 base 3 all over log 3 to the power 2 base 3. Okay, and from here we can invite the third law. That is, this 2 should come and multiply this here, to come here, to multiply the log 3, base 3. So log 2 minus 3x base 3 is equal to log 6x squared minus 19x plus 2 base 3 over, and this is 2 log 3 base 3. Okay, so but log 3 base 3 will be 1. So here will be just 2. So log into bracket 2 minus 3x base 3 equals log into bracket 6x squared minus 19x plus 2 base 3 all over 2. Then this 2 should come and multiply this. So that is cross multiplication. So this is 2 log into bracket 2 minus 3x base 3 equals log into bracket 6x squared minus 19x plus 2 base 3. Okay, we can still move this one to that side. So log into bracket 2 minus 3x squared, that is those two coming here, is equal to log 6x squared minus 19x plus 2 base 3. Here 2 is base 3. So the same base, we can equate the rest, what's in the bracket. So 2 minus 3x squared equals 6x squared minus 19x plus 2. Okay, I want to use the binomial theorem to expand this. Okay, so this is going to be 4. This 2 squared is 4. Then 2 times 2 times 3. That is 2 times 2, 4 times 3. So minus 12x. Then this will be plus 9x squared. Okay. Then equals 6x squared minus 19x plus 2. Now from here, I want to send everything to that side. So this is going to give me, no, let me bring this one here so that I want the x squared to be positive. So though I'll get positive, but I want it to be simple for me. So let me bring those here to this side. So that is 9x squared minus 6x squared. Then minus 12x plus 19x. Then plus 4 minus 2. So plus this 4. Then this coming becomes negative 2 equals 0. Okay. So this is going to be 3x squared. Now 12, negative 12 plus 19 is plus 7x. Then this is going to give me plus 2 equals 0. So now I have this simple quadratic equation to solve. Now I'm going to go by the factorization method. Okay, so by the factorization method, I am going to multiply these two, 3 and 2. So that is going to give me 6. And then factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, so here I think I can choose 1 and 6. And this is positive 7. So it means I need to choose positive 1 and then positive 6. So I'm choosing positive 1 and then positive 6. Okay, so 3x squared plus 6x plus x, that is 1x, the 1x plus 2 becomes 0. Okay, now from here I have 3x because 3 can divide this and this one, and then x is here, x is here, so 3x, then x minus 2, so x plus 2, sorry. That is, this and this is 3x squared, this and this is 6x. Then on this side I have plus 1 out, x plus 2 equals 0. Okay, let me continue just from here. So those outside bracket, we have 3x plus 1 and then x plus 2 equals 0. So 3x plus 1 equals 0. We have x to be 1 over 3. That is this, sorry, negative 1 over 3. That this goes to be negative 1. And then divide both sides by 3, you get negative 1 over 3. So negative 1 over 3. And then on this side too, we have x plus 2 equals 0, and that is x becoming negative 2. Okay. So let's meet in the next class for more examples on change of base. Please don't forget to subscribe, like, and share. Thanks for watching. Bye.